Chapter 3A, Section 3.1 is about the history of the atom, where we look at the rise of the modern atomic model of the atom, and we look at the discoverers and their contributions. So we'll start with Democritus, and he's the first person that just thought up the idea of the atom, where he figures matter has to get to a point where it's so small that it absolutely can't get any smaller. So the particles of matter cannot be broken down any further. So he names this the atom, which in the Greek meaning is indivisible, can't be divided any further. So this is what a diagram of his model may have looked like, pretty much just a sphere, because again, he's only theorized about it, he's not proven anything. Then John Dalton comes along much later, and he refines Democritus's definition by coming up with theories using his ideas, such as all atoms of the same element would look the same, and all atoms of different elements would look different. And if you combined two or more atoms together, then they would form more complex substances known as compounds. So he had several other ideas, but the majority of them were correct. However, he still has not performed any experiments and thus hasn't proven anything yet. So Dalton's model would continue to look like this. J.J. Thomson does actually perform an experiment known as the cathode ray experiment, in which he discovers with that experiment negative particles. So these particles are named electrons. Recognize that in his model, if there are negative particles present, then there must be something positive to balance the negative. So we have to have a positive mass. And so he called his the plum pudding model, where there's this giant plump positive mass of pudding, and then inside are these negative plums that are spread out within. Rutherford discovers the dense positive center known as the nucleus. He performs the experiment known as the gold foil experiment, where he shoots alpha particles, which are positive, to gold foil, and then he's expecting, if J.J. Thomson's model is true, that the particles would just go straight through J.J. Thomson's model of the atom. So positive particles would just shoot right on through and not actually bounce backwards or be deflected. However, we find that when he does the experiment, some of the positive particles are deflected, and therefore Rutherford discovers the nucleus, which is a dense positive center made up of protons and neutrons. So here's another picture of it to just emphasize that the nucleus has a positive charge, it's very dense, compact, and in the center, and it's surrounded by negative electrons. So here's what we have so far. Democritus and Dalton just think up the idea of the atom. Then Thomson, using his cathode ray experiment, discovers the electron. Then Rutherford comes along with the gold foil experiment, and he discovers the nucleus, where he realizes there is a dense positive center. Therefore, all of the positive, or the protons, are in the center of the nucleus, and the electrons are surrounding it. We'll find later, when we go into more detail, that Niels Bohr and the quantum model describe what's going on with the electrons on the outside of the nucleus. We're going to find that Niels Bohr explains that the electrons are moving around the nucleus just like planets move around the sun. However, in reality, the electrons move more like bees around a beehive. Some of them move in a figure 8, some of them move in a circular motion, and so we have to take into account these different maneuvers. And again, we'll look at this a lot more when we get into later chapters.